Okay. And the last one that we've drawn, right? This is in fact equal to the tau max. It's the biggest among all the three circles, right? So for this case, what we have seen now is tau max is equal to shear max xz, okay, which is equal to shear max zx. And from here, we can see to calculate tau max is stress x divided by 2. Okay. And what we realize that the maximum shear stress is the what? At the out of what? Out of plane. Okay. Where we know that stress max is equal to stress x and stress mean, which is equal to stress z. Right? We can see that. Right? Now, this highlight what is the importance of 3D Mohr circle. Okay. Whenever we deal with 2D Mohr circle, okay, so if we look at 2D Mohr circle, let's say we did not do 3D Mohr circle, we just look at 2D Mohr circle. So you just draw this, just draw a 3D. We ignore the 3D plane, right? So this is our stress x, this is our stress y, right? Even for this case, both situation, whether it is 2D or 3D, stress z is equal to 0. Right? So for this case over here, stress z is also equal to 0. For this case over here, stress z is also equal to 0. Right? So if we just draw stress x is greater than stress y, the 3D case is also the same. Stress z is equal to stress y. The problem is this. Okay? The problem is this. If you analyze it in 2D, right? You realize that your tau max is equal to your shear xy, which is equal to shear yx. Right? In 2D, you only draw. So in 2D Mohr circle, you only draw this circle for 2D analysis. Right? Which is wrong. Right? You have to look at it on the 3D line now. So on 3D, you have stress equal to 0, right? And then your shear stress will be what? Your shear stress will be tau max is in the what? Out of plane regime. Right? And if we totally ignore it, our structure will fail. If we totally ignore this, our structure will fail. Why? Because we ignore the out of plane. Because for this case, the out of plane is going to be the biggest diameter, and if failure is going to occur, it's going to occur at where? At the out of plane maximum shear stress. Right? So for 2D, right? So for 2D Mohr circle, so I'm going to write down here. Okay, so this is just for what? 2D, right? And this is your tau max for 2D, which is smaller than your tau max in 3D. So this is 3D Mohr circle. And I like to highlight over here, both 2D and 3D, right? What did we say? Stress Z is also equal to 0. Okay. Stress Z is also equal to 0. Both are in the same stress field pattern, but the analysis, one is on 2D, the other one is 3D. And then when you do 3D, you realize that your maximum shearing stress is now tau max, and now this is your what? Your out of plane. Okay, so that's why it's important to be able to understand or to construct not just 2D Mohr circle. 2D Mohr circle is the fundamentals. Okay, fundamental of it. 3D Mohr circle is critical. Okay, only in 3D Mohr circle, then you can pick the what? Then you can pick the right material. Okay, so what I'm teaching you now is a build up, right? Initially, we do compound loadings, right? We do shaft, we do beams, right? We do compound loaded structure with both bending and both shear, and then with torsion, and then we do a bit of 2D Mohr circle. So in reality, we have to introduce 3D, Okay, we have to do 3D Mohr circle. So with this value over here, right, now you know your tau max, right, your shear max, then you can choose your material. Okay, and this is critical when material fail in what? In shear. Because in 2D Mohr circle, your maximum stress is still at where? Stress X. You have no issue with that. But it's the shearing that's going to cause you the what? It's going to be causing you the problem. And a lot of times when we are unsure, what do? We put a factor of safety. Yes or no? Okay, I'm going to do 2D Mohr circle analysis. I forgot how to do 3D Mohr circle. Okay. Safety of safety 2.5. Okay. Factor of safety. The bigger the number. What does factor of safety means? The bigger the number, what does it mean? Anyone?
The bigger the stress.
No, the bigger of safety means you know nothing. You know less. Yes or no, right? Pardon my French. I like to call it. I'm not going to edit this. I call it the number of full of shit. Okay, if the engineer has full of shit, does not know what he or she or it is doing. Okay, we put a safety factor of 10. Then every structure that we build looks like the bloody pyramid. Yes or no? Okay, no, we have to go 3D. Okay, right. So this is condition number 1. Okay, we are going to condition number 2 now. So I'm going to use the same uh, figure. Okay, I'm going to use the same figure. All right. So everything the same. Now the condition changes. I'm going to change the condition. All right. So the condition is still the same. We're going to still use the same element. All right. So sorry, the condition. So condition number 2 now. Okay, condition number. So we have condition number 2 where stress Z is equal to 0. Now stress X is positive. Sorry, stress X is negative. And stress Y is what? Positive. So I'm going to flip the arrow around. I'm going to flip the arrow around. You got compression now. Okay. So what will happen now to our Mohr circle? Okay, what will happen? The Mohr circle you'll still get 3 circle. The critical part is the shearing stress. It's the maximum shearing stress in plane or out of plane. Okay. So for this case, again, I'll draw here. Okay, and I'll try to use the same scale like what I had before, so you can see better. And then yeah. So one is our normal stress, shear stress. Yep, about the same. I'm going to extend this a bit longer. To maybe here. Yes.
When we're saying in plane and out of plane, we're referring to in the plane of bending, right?
No. In plane
Okay, what
means
is that?
in plane is the area that has the element that has the biggest surface area. I've been through this with you guys, right? So if I'll recap it. If this is our element, right? Now this becomes our in plane, and the rest becomes our out of plane. Nothing to do with the loading condition. It's how it's which surface area that is the biggest. It's called your in plane. So if this is my transformation now, X, Y, and this is my Z. So now my XZ plane is my in plane. And then my out of plane is my YZ plane. and my out plane is my XY plane. Okay, does that make sense now? Nothing to do with the loading condition. Okay, nothing to do with our loading condition. I tried reading it like you. Okay, I tried. What is the in plane? What is the out plane? Get nothing from bloody textbook, unfortunately. It's so called this is known. You get what I mean? So I will tell you this is known now after me explaining. Right. So now,
Eugene,
yes.
so what if we have a cube in like reality? Like, how do we know which is in plane and which is out of plane?
So yes,
Like a cube structure.
yeah. So yeah. So it's the surface area. So if you have a cube structure, right? So this is your overall structure. Yes or no? So this is your overall structure now. So if it's this surface that you're interested, right? If this surface you're interested, then you put your element on top, right? So you will know which is your in plane now, right? If it's this surface that you're interested, then you draw your element over here. You put your element over here. Does that make sense now?
Yes.
Okay, so you don't draw a cube as an element, means there's no in plane and there's no out plane. Good question, by the way. Okay, right, coming back to here. So we know that this is our stress Z line, and then we are going to have our line over here. So we say that over here, this is our stress X line, and then we have another one. Okay, so I need to control. Okay, so let's say over here, this is your stress Y, right? So all of them have zero shearing stress. Okay, so this is your point X, this is your point Z, and this is your point Y, right? So you draw your two circles first. I'm going to draw the smaller circles first. So I'm going to have, so over here, okay. So over here, this circle belongs to what? This circle belongs to our exact plane, right? So this is our exact plane. So our exact plane over here, okay, like what we see over here, our exact plane is our out of plane. Okay, so this is out of plane. Okay, so sorry, for our case, this is our in plane. Okay, then we draw another circle. So again, if we're going to label this in terms of shear, right? So this is our tau max in our exact plane. Okay, so like before, same, right? I mean, the label is the same. Okay, then the next one is our YZ. Okay, so I'll draw my YZ circle. So 6. So over here, this is your YZ plane. Again, this is your what? Our plane. Okay, this is our plane. And now final circle, the third one. This one, right, becomes the biggest now. Okay, so this circle over here is our XY plane. And our xy plane now is our what? In plane.